All right, in this video, we're going to learn about Module 4, Lesson 4, and 5. So Lesson 4 is about correlation and causation, and Lesson 5 is about linear regression. So these are talking about our benchmarks DP.1.3, which is explain the difference between correlation and causation in the context of both numerical and categorical data. And then also DP.2.6, which is given a scatter plot with a line of fit and residuals, determine the strength and direction of the correlation. So we're going to interpret strength and direction within a real-world context. So what is correlation? Well, correlation is just the relationship between two variables in a data set. Okay, so if these are the data sets or scatter plots that I'm looking at, there are some relationships or non-relationships here. This first scatter plot is no correlation. They don't make a pattern, they aren't close together, they're scattered all apart, and when there's no correlation, the x and y are not associated, so there's no relationship. In this next scatter plot here, we can see that there is a correlation, and it's a positive correlation. Okay, when there's a positive correlation, then as your x increases, your y increases. So as one goes up, the other goes up. So they have the same relationship. And then finally, in this scatter plot, you can see that it looks like it's going downward. So that's going to be a negative correlation. So what happens here is as my x is increasing, my y value right here is actually decreasing. So they have an opposite relationship. As one goes up, the other goes down. So that is no correlation, positive correlation, and negative correlation. Now, you can also have you can also be strong, medium, or weak when it comes to correlation. So this first example, again, random points, no pattern whatsoever, not close together, but they would have a weak or no correlation. And so when the points are scattered and there is no pattern, then there is no correlation. And the second graph here, on this second scatter plot, we can see they've clumped together a little bit more, but they aren't creating a straight line or a complete pattern. They're just a little bit closer together. So they have a moderate correlation. So when your points form a pattern but are spread apart, meaning loose, then there is some correlation. And then we have a strong correlation. See how close together those points are on that scatter plot and how they almost create a complete line? Well, then that means that there is a strong correlation. So let's talk about causation. When a change in one variable produces a change in another variable. So in other words, when something causes something else to happen, we know this as cause and effect. Correlation versus causation. So when two variables are correlated, so first we have to determine if they're correlated. That does not necessarily mean that the change in one variable is causing the change in the other variable. So one careful thing to take note of is that correlation, just because something is correlated, does not necessarily mean that it's equal to causation or one is causing the other. So we'll see some examples of this in our next slide. So in example 1, it says the data shows that per capita consumption of mozzarella cheese and the number of civil engineering doctoral degrees awarded in the US. So we're looking over here at this graph, and on my y-axis I have my civil engineering doctorates, and on my x-axis I have my mozzarella cheese consumed in pounds. Now looking at this data, I can see that it looks like it's correlated. As my mozzarella cheese is increasing, my doctorates are increasing. So great, they're correlated. And it's a strong correlation. So they have both a positive and strong correlation. But does that mean that one is causing the other? Does the amount of mozzarella cheese one person is consuming, is that causing them to get a civil engineering doctorate? Well, the consumption of mozzarella definitely does not cause anyone to obtain a civil doctorate. So these two variables do not have a causal relationship. Now, this is a pretty drastic example. We clearly and logically would not think that mozzarella cheese consumption and civil engineering doctorates are related. But this is something that you could say is correlated, but is not causing the other. So why don't you go ahead and take a look at this check and try it on your own. I'll give you just a few minutes and then come back, or you can pause the video and come back and check your answer. But these are pretty easy. So the data shows a relationship between how many hours parents sleep per night and the number of children they have. So we need to determine the correlation. Well, first, let's take a look. Here are my data points, and it looks like they're trending in a downward motion. So they're going to have, as x is increasing, so as my x value, so as the number of children are increasing, my amount of sleep is decreasing. So they have a negative correlation, and I would say it's about a moderate to strong. So because they're a little spread apart, they're not as close together in the last one. So I would go with a moderate strength. Now we have to determine causation. Now, when we're looking at this, do the number of children you have, or the more children you have, is it causing you to get less sleep? Well, not necessarily, because some parents, they're so tired, they could be getting more sleep. Also, you'll look at this data and it has 3 outliers. So these points that are not with the clump or cluster are called outliers. So yes, the data suggests that they are correlated, but could there be another reason or another variable that is affecting the parent's sleep? And there's many different variables that could affect their sleep. Where they live, do they have dogs, how much do they work? And because other things could be affecting what is causing or not causing them to sleep, they do not have a cause and effect relationship. So again, this is not a causal relationship, even though it is correlated. So what about those outliers? What could be causing those outliers? Something for you to think about, but there are 3 outliers in this example, and though we're not talking about it in these particular benchmarks, it's something to take note of, and I'd like to hear your ideas about what could be causing those outliers. All right, here's your practice. You're just going to do 3 practice problems and complete them in Canvas, and then you'll be able to check your work. That's the end of this module 4. Bye.